What? That's a shortcut. That's the shortcut. You need to go for the long version. That means what I showed here previously. 2 circles, 2 DC voltage sources. You need to bring them in. Okay? So 2 DC voltage sources. EDC 2 copies. One here, another there. And also you need to what's next? 3 pieces of resistors. One here, one there, another here. Okay. Then that what is that? Source. AC voltage source. Sinusoidal in nature. So V sign is going to be the name. VSIN. Where is it? 1 copy. It goes here. Anything else? Do we need anything else? We need ground. Okay, otherwise the software is not going to work. Okay? So where is the ground? Many copies are grounded over here. I'm going to use just 1 copy known as GND_analog. You just type GND, it's going to pop up below. Okay? GND_analog. How many copies? As many as you need. How many do you see? 3. But what about them? What about them?
5. Oh.
No. Is this a ground?
Yes.
Think about the longer version. 2 sources joined. That point is known as ground. Okay?
That means 4.
Well, we can directly, just something popped into my mind. This is a shortcut, we can't do it over here. You can definitely go for the longer version, but there is another shortcut. Okay, some intermediate. Okay, not the full, not the shortest. Somewhere intermediate, okay, somewhere in the middle. So, I'm gonna show you that, no problem, but I'm gonna need 2 grounds. Okay, 2 grounds. Why 2? You'll see. Soon you'll see. Why 2? 2 more. 3 from there and 2 due to this medium shortcut or whatever. Okay? So 5 pieces altogether I'm going to bring in. 1 here, 2 where? There, 3 here, 4 here, 5 there. Yeah, done. So done with all those shoppings. Now let's do something. Look at there. What do you see on top? Minus and plus at the bottom. You see that? What's the case over here? Plus on top, minus at the bottom. A little bit problem. Okay? Don't try to, you can work with this structure, no problem, but the outlook of the circuit is going to be a little bit different from this. And it's going to cause some problem. Okay? Because you need to understand it. Okay? Whatever you build, you need to understand. That's why what I'm going to do is that I'm going to change this guy in such a way so that minus is on top and plus is at the bottom. How to do that? Well, this is the way. Rotate it twice and flip it once. Okay? So, I'm going to rotate this guy twice. I've already selected it. So, rotation, Control R twice. You see? Minus is on top. Now, plus is at the bottom. But problem, it's facing this way and that facing this way. The opposite. How to change that? Flip it. Okay, Control F. That's it, done. So let's keep this guy, let's move it here. And now let's go for the power supply. Let's go for plus B. Okay, plus B. Let's bring this guy in this way and keep it here. Well, there's another problem. The problem is usually when we draw our circuits by hand, we keep the plus guy on top, positive on top and negative at the bottom. You see that? For power supply, plus, minus, positive, negative. But this guy, this software is a little bit different. It's just the opposite. Look at that. V minus. Okay? Negative power supply is on top and positive is at the bottom. Okay? Although this is gonna be, we cannot change it. But our main target was this guy. If you do not follow this pattern, the circuit is gonna have a different outlook, which is a problem. But if you do not follow it, if you reverse it, no problem is gonna occur. That's just a small thing. Small thing. Ain't gonna cause any problem. That's why we're gonna just accept these two people. Okay? But keep it in mind. Plus V this minus V that, and do it accordingly over here. So this is V minus. That means negative power supply. That means talking about this guy. Okay? So whatever you wanted to do here, you do it there. Okay? Let's see how to do. Well, I did something over there already. Please keep an eye there. The minus terminal of the source. Minus terminal of the source. The minus terminal of the source is going to be connected to this guy. Okay? You can bring out your big picture. That big picture. You remember? Plus, minus was connected here. Minus, you see? Minus is connected here. As it is. Exactly the same. Okay? But what about the plus? What about the plus? Where did you have the plus? The plus was known to be the ground. See? In your node. Plus is known to be the ground. That means this plus should be connected to ground. Okay? Where is the ground? Somewhere close this guy. Okay, so let's rotate it twice and let's keep it on top. That's it. That's the way. Similarly, what about the bigger picture? For plus V, plus minus. Plus should be connected to this place. Okay? And minus to ground. Well, this is the terminal. So let's attach the plus here and minus to ground. This one here, that one there. Am I clear? Now let's configure them. What was the name? VS1 was the name. So VS1. Similarly, what was the value? 15. This is reality. Don't go for negative values. This is reality. Okay? So all positive should be there. V2 should be changed to VS2, and this 0 volt should be changed to 15. Look at that, both are 15. If you follow the bigger diagram, which I showed you previously earlier, okay, both voltages were positive, 15, 15, top, bottom, okay? So 15, 15, don't go for any minuses in here. Okay, this is reality, so all positive. So VS1, 15, VS2, 15, but due to the connection, depending on the connection, this guy is going to be negative, the normal voltage, and that guy is going to be positive, the normal voltage. One more thing to do, I'm going to flip this guy as well, in order to have the name onto the left and the value to the right. Also the same for this guy. So that's it. Now let's go for the other items. Did you see what I did? I configured the triangle at first, then the power supply, and then I'm gonna go for the other items. Repeat this thing, this process, this procedure everywhere. Okay? Whenever you need to do something with the operation amplifier, get the operation amplifier. Fix it. Then attach power supply. Then go for some other connection, not the other way around. Okay? This is the basic practice. How did I get it here? Flipping, Control F. Okay? Well, I'm going to attach this ground over here with the plus terminal. Then I'm going to keep this guy somewhere here. Attach it like this. I'm going to change this name from R1 to RI and the value from 1K to 10K. Now get this guy, put it somewhere here, connect it, and somewhere below I have a piece of ground. So well then let's configure this guy. What's the name? The name is VI, so VI. And by the way, I need to move this name onto the left, but flipping is not an option. If I flip, this is going to occur. The sinusoidal symbol got changed a little bit. That's why I'm going to move it directly. So select it and then use the mouse to move it. This way. So done. Then let's get inside this source because we need to configure the amplitude and the frequency. So double click. Well, you're familiar with this, supposed to be. So 3 items to fix. Number 1, VOFF. Number 2, VAMPL. Number 3, FREQ. Okay? VOFF is nothing. Just simply keep it in mind. You need to set it to 0. Nothing else. You don't need to understand its definition. So VOFF is going to be 0 volts. Either click Save Attributes or press Enter. VAMPL, this guy is going to be 1 volt. 1 V. And by the way, you know it already. No space between number and unit. No space. FREQ is going to be 5008Z. 500 Hz. Okay? Click on OK. Here you can see amplitude and frequency because I have put it that way. But do you see that? Over here. Do you see that over here? No amplitude, no sign of any amplitude or frequency. It's inside. You can bring it out. You can show it. You can display it. Let's see how to do that. You may already know it. VOFF is not needed over here, so forget that. You're going to display VAMPL and FREQ. How? Select VAMPL, select Change Display, then go to this box which says what to display. Currently it's none. That means nothing is displayed. Okay? You select the option in the middle, both name and value. You show both name and value. Click on OK. Done with VAMPL. Do the same thing for FREQ as well. FREQ, change display, what to display, both name and value, OK. Finally you're done, click on OK. So you see, both are there, overlapping, one on top of the other, OK. Separate it. Select the first one, bring it somewhere here, select the second one, keep it just below. Get done. See? Easy. Double click, select the parameter, for example VAMPL. Click on Change Display. Then go to What to Display box. 5 options are there. Currently none should be selected. You select the option in the middle, the number 3 option from top, okay, which says both name and value. And click on there, click that option, click on OK, again click on OK. You'll be able to get it on the diagram. And do the same thing for FREQ, same process, okay? Now, let's go for RF. RF, where is that guy? Somewhere here. So, I'm gonna keep it where? Here, and attach it this way. Name should be RF, value should be 100K. You see? So I have configured RF 100K. Now this resistor, make it vertical, then keep it somewhere, let's say here. No, farther apart. There. Then a little bit below. Then something like this. Name goes like RL. Value is 10K. Almost done. Almost done. What's the difference between these two figures? Only this guy. This is absent there. I'm gonna bring it in. Okay? How? Using some text box. I'm gonna type something. So this is a text box. Click here. You got a pencil. Now click somewhere. For example here. You got a movable box. Okay? Just select a big size at first and then click again. Okay? So finally you get a solid box. Inside the box you see a cursor. You just now start typing. For example, what do you need? Plus, VO, minus? Okay, let's go for that. Plus, VO, minus, like this. But then again, I'm gonna leave one blank line before VO and after VO. Okay? Then I'm gonna reduce it later. I'm gonna move the whole box somewhere here just to place it correctly. Okay, let's go for some more separation. 2 blank lines. Yeah, looking nice. Okay then. Now I'm going to reduce the box, reduce the size, and you can see a border, green border around it. I'm going to remove the box as well. How to remove the box, the green box? Double click on the border. You see the green? This is the color of the frame. I choose it to be none. That means there should be no color of the frame. That means the frame should be, in other words, invisible. That means no longer there. I mean, it's there, but you won't be able to see it. See? The border is just away. Okay then, that's how you do it. So done finally with the figure, with the circuit, yeah. This box. That box. Okay then, so this is the circuit. Now, how to get that? How to get this guy? You need to tell the software, you need to get a graph with time on x-axis. That means, in other words, you need to go for transient analysis. Select setup analysis, go for transient, and keep an eye on the top box, the box on top, not the box at the bottom. Forget Fourier analysis, we don't need that. We need this guy. But then again, not all options are applicable. Forget print step, you don't need it. Final time needed. Okay? What should be the final time? Depends upon the number of cycles you want to get. Okay? You usually start with 0 and end somewhere. Okay? Depends upon the cycle. If you want to have 1 cycle, you go for 2 milliseconds. Final time should be 2 milli. If you want to have 5 cycles, 5 2s are 10. 10 milliseconds should be the final time. Okay? But the rule of thumb or usual rule is to have as many data as possible, not just a few cycles. So we're gonna have basically 100 cycles, the first 100 cycles. You may not be able to understand it here, but may be able to understand it in some later courses, that taking just a few data, few cycles, first few cycles is not just enough. Sometimes you may need to go for first 1,000 cycles even. Okay? So right now we're gonna take just first 100 cycles. How many milliseconds? 100 cycles. Each 2 milli. So 200 milli. No print delay not needed. Step ceiling, I suppose you know its meaning. To put it simply, it's just a gap between 2 data points, 2 dots. Okay? Then again, in time, not in voltage. Okay? So, step ceiling, you take 2 points, you find out their gap in x-axis according to time. That's the step ceiling. Okay? If I put it simply. Not exactly like that, but then again, you don't need to go that much further. How should you select that? It should be very much small. Why? In order to get a smooth curve. Okay? But then again, not too much small so that you generate lots of points and employing a lot of time. Okay? So what's the simple rule? Whenever you have any periodic structure, get the period divided by 50, and that should be a small value compared to the period. Okay? So this value should be small compared to the period, and that's the value, t by 50. What is t here? 2 milli. What is 2 by 50? What is 2 by 50? 0.04 millisecond. Then a couple of points at the bottom, and we don't need it. Forget that. So that's it. Final time, step ceiling, you're done with transient analysis. Click on OK. Click close. Yeah? Step ceiling is going to be 0.04 milliseconds using t by 50. That rule. Keep it in mind. You'll need it in future. Told you already. I'm going to show you many small items here, but you need to do it on your own later for other circuits or other experiments. Okay, now time to tell which voltages we need to see on the graph. We need two, VI and VO. VI, VO. Both are, look at that, plus minus ground, both are nodal voltages. Okay? We need to mark it over here. We need to tell the software we need those two items. How do you do that? Using markers, voltage markers. Here, markers. First two are voltage, then number 3 is current. This guy is a nodal marker and that guy is a non-nodal marker. Because these two voltages are nodal voltages, we're going to use the first marker. Mark voltage on level. This one. Okay, where to put it? Where you have the nodal voltage, put it there. For example, we have a nodal voltage here. Okay, here on this node. So we're going to keep one copy here and another nodal voltage there. So one copy there. Done. These two people, these two bubbles are going to give us VI and VO respectively. Okay? Two things. Now save it. Finally. Well, you need to see, okay, doing transient means getting the x-axis, not the y. On y you need two people. How do you tell that? By attaching markers. These are voltages. You need voltage marker. Two voltage markers are there. One for nodal voltages, one for non-nodal voltages. These two, according to their outlook, is nothing but the nodal voltage of this node and that node. That's why we're going to use two nodal markers. Okay? You can get it from marker menu, and the first option, mark voltage / level, is the nodal marker. Okay? You take it and you keep one copy, place one copy here, another copy there. That's how you do it. Okay, so done with saving. Now how to simulate. So this is the process. You have seen the same process over and over again. 202, 204, 206, everywhere. So you should be able to, figure it out. So, design manager. Number 2 option from top, run PSpice. Something is going to appear. This is that guy. Well, where is it? Yeah, this guy I'm talking about. This guy appeared just. Okay, so 3 windows you can see over here with nothing inside now. We'll use it later. Get back to the circuit here. Click on what you call the simulate button. This button. Click on it. And then you'll get back that blank window again with some new information in it. See? That's the window with some information now. Let me just maximize it. You don't need to use this box. Forget that. Start with this. What's the last line? Simulation complete. What does it mean? This guy doesn't have any errors. If you have any error, you'll be able to see some messages, error messages. Then you need to just go through them, understand them, solve the problem, then simulate again. Okay? As I do not have any problem, so I'm jumping into the graph. This is the graph, the big box. This is time x from 0 up to 200 milli. 0, 200 milli. First 100 cycles. Well, this is the y-axis. What do you have here? Supposed to have VI and VO. So 2 items, their names, and also their symbols. This is VRL2. RL2 means this is referring to VO. RL, you know. VRI1. RI, this is referring to VI. Okay? So that's it. The names are a little bit clumsy, a little bit different, but you know, if you go through them, you'll be able to understand what they mean, what that means. Okay? So that's it, done. Now, how to work with this? Plenty of items over here. Plenty of items. Okay? If you keep an eye here, what do you see? Something, yeah, something. If you go here, what do you see? Yeah, I can see, yes, the same thing maybe. If I go at the last position, okay, last box, I see the same thing. Whenever you see the same thing everywhere, then that means you can work on any portion you like. Okay? So I'm gonna simplify this guy a little bit. I'm gonna keep too much information here. I have many information in my pocket, but I'm gonna work on a smaller portion. Okay, smaller portion. Now choose which one to choose. I'm gonna choose the last box. Okay, last items, last few cycles. Now question, how many cycles? Let's say 5 cycles. I'm gonna select 5 cycles. Last 5 cycles I'm gonna work on. Okay, so I'm gonna keep in this box only the last 5 cycles, and I'm gonna just remove other items. Remove. Okay? How to do that? You go to plot. You go to axis settings. Because I can use the time information for last 5 cycles in order to refine it. Okay? So that means I'm talking about the axis. That's why I need to go to the axis settings. And then again, two axes are there, X and Y. I need to work on X. Told you already. So X axis here, already selected. Forget other items, you need to work on data range. Because talking about values. So data range. Auto range, user defined, 2 options. Auto means full. User defined means you can modify, you can customize, which I'm gonna do right now. Okay? So user defined. This is the start and there is the finish. What is the finish? Last 5 cycles, 200 milli. Last time. So 200 milli, done already. What about the first one? 5 cycles behind, before 200 milli. 1 cycle is 2 milli. 5 cycles is 10 milli. So 10 milli before 200 milli. 190. So 190. That's it. Click on OK. So already defined. Only the last 5 cycles are here. Now 2 curves, both are thin. So make them thick. Increase the thickness. How? Keep the mouse pointer on top of a curve, then right click, then click on properties, then select the width, select the number 3 option from top, 3rd option from top. Click on OK, so thickness increased. Similarly, get to the green curve, right click, properties, well, where is that? Width and 3rd option from top. Click on OK, so it got increased as well. Okay? Now it's clearly visible. Nice. Even you can try matching it with that. Okay? Exactly the same. Exactly the same. One thing is just remaining. VIVO. You need to attach those labels there. Okay? So let's go for VI. Let's see how to attach this VI label. The red one is the VI curve. You need to select a particular point in order to attach a label on that. Okay? So let me just select. Let's say this point, I'm going to select and tell the software to attach a label over here. How? Now how do you select that? Using cursor functions. Okay? So let's bring in the cursor, which is this guy. Toggle cursor. You click that. You get 2 cursors. Once you click it, 2 cursors. One horizontal, one vertical. Okay, line is going to make up a cursor. So you got 2 of them. One works with the left click, another works with the right click. So left cursor, right cursor, like that, you keep in mind. Okay? Both cursors are gonna be on the first curve. First means what? From left, whichever are first. That means 2 I have from left, this one is the first. So this guy is gonna have 2 cursors by default once you click that. Okay? And how do you identify it? Do you see some boxes, a dotted box around the, what do you call, symbol? The box identifies the cursor. So where do you have the cursors? Both cursors, 2 cursors? Here. Do you see any box over there? No. So that guy doesn't have any cursor. So I'm talking about the red guy. So this is the red guy. This is supposed to have at least a cursor. Now you choose what cursor you want to have there. I'm going to choose the left cursor. Okay? So I'm going to bring in the left cursor on the red curve. How? Question is how? Get to the red symbol. There. Click the left button. Left mouse button. You need to bring in the left cursor. Click the left mouse button. Once. Done. So one box got moved to red. This is the left cursor. While another box remains here. That was the right cursor. Okay? Forget the right cursor. Again, we can use only one cursor to just solve our problem. Now I have a cursor on the red curve, and I'm gonna Okay, let's get in the region. So mouse pointer here. Now I'm gonna left click and hold and move the mouse in order to move the cursor along the red curve. You're gonna see it. Okay, so left click and hold. Do you see something moving along with the mouse pointer? Do you see something? Is it visible? Should be visible. Something is moving. That is the cursor. I'm gonna keep it on my desired point. Yeah, there. Right now the cursor is pointing to that point. So I selected that point. Now I'm going to tell the software to put a label on that point. Where is it? Here. You see? Mark label. Click that. What do you see? Something just appeared with a straight line segment. This is like an arrow pointing to that point. The coordinate of this point is here. Coordinate means x comma y. X value comma y value. You don't need that coordinate. You need only this guy, vi. So you edit that. How? Turn off the cursor at first. Click this button. Then click once. Sorry, not once. Double click on the label, on the coordinate. Double click. You get the coordinate there. You remove it. Type vi, whatever you want. Click on OK. So now you can see vi over there. This is how you attach the label vi. Similarly, you attach the label vo. Okay, let's do it for the green curve. So cursor, left cursor, right cursor, both are on green. I'm going to choose the left and suitable point, let's say here. And then I'm going to attach the label, turn off the cursor, double click on the label and remove it, type vo, click on OK. So got it done. Okay, let me just show you the print preview. In that case, you'll be able to see the cursor. Or not the cursor, but the label. You see? VI, VO. Like that. Okay? So finally we're done with the graph. Now, what to submit? In the report, the circuit and the graph. Not these two, but those two. Okay? So, submit this circuit. Submit this graph with the labels. Okay? How to do that? Let me just show you the process. You already know that, but then again, let me just show you. Maximum zoom reduced by 2 steps, 2 times zoom out. Select, the whole circuit using a box by dragging a box around it like this. Box. Edit. Copy to clipboard, not copy. Copy to clipboard. Then Microsoft Word. And then you know how to set up the page, whatever, you know. You can do it on your own. I'm gonna just paste it. You see? Now you need to, forgot. There are plenty of dots here. Before clicking copy to clipboard, remove those dots. How? Options, display options, grid on. Check that option off. Okay? Check it off. Then the dots are gonna disappear. Then click on copy to clipboard. Then paste it. So this one, delete it. And the new item, where is it? I did something wrong. Okay, so this is the correct figure without the dots. Now remove the border around it. How? By cropping. This is the crop. So you do something like this, then that, then this, and that. Okay? So I removed all the borders, but please don't remove any necessary items. Okay? For example, don't do something like this. Something like this. Okay? Whatever you have in those shades, in those gray area is going to be deleted. Once you're done, click outside. So, got rid of the border. You need to submit this figure. Okay? But please ensure whatever you submit, it's visible. Make sure it's visible once you print it out. If it's so small that we cannot see, then you'll lose your marks. Okay? Make sure it's visible. How to get the graph? You don't need to copy it to Microsoft Word. Okay? Just directly print it out from here. And by the way, don't go for any screenshot. Okay? No screenshots. Just go to File, and you know how to print. You can figure it out by yourself. Let me just show you the print preview. So this is going to be the output. Once you print it out on an A4 page, this is going to be the output. Perfect output. Am I clear? So this is how you get the circuit and get the graph. Yeah. You need to select a couple of items, a couple of options. You can figure it out on your own. You've printed so many times, so many things. Okay. Well, so that's all about the inverting amplifier, and told you already, I have gone with much more details with the inverting amplifier. Okay? That guy is gonna be a homework. Whatever I have shown here, repeat each and every step there. Okay? To get it done. That's it. Yeah, both should be there in the report.